the angle of rotation for regular polygons. What is that? This means that to what degree can we rotate a figure to have it map onto itself? In other words, how much can we rotate this figure to make it look exactly the same as we started? Let's start with this. No matter what figure you have, if you rotate it by 360 degrees, it will look exactly like the figure you started with, the pre-image, no matter what you have. So let's start with that number. Here we have a square. In order to find out what degree we can rotate the figure to, other degrees other than 360 degrees, all you have to do is count the number of lines of symmetry it has. So here, a square has 4 lines of symmetry. 1, 2, 3, 4. And you take 360 degrees and you divide it by 4. And that equals 90 degrees. So if you rotate this figure 90 degrees, it will look exactly the same as what you started with. And again, if you rotate it 90 degrees twice for 180 degrees, it will look the same. If you rotate it 270 degrees, another 90-degree rotation, it will look the same. Now, an interesting thing to note here is that the number of lines of symmetry also correspond to the number of vertices this figure has. A square has 1, 2, 3, 4 vertices. So rather than trying to figure out how many lines of symmetry a figure has, especially when you get to one with lots of different lines of symmetry, like tons, 10, 20, it's a lot easier to count the vertices than it is to count the lines of symmetry. So using that, let's try to figure out how many lines of symmetry this figure has and its angle of rotation. Take a minute to pause the video and figure that out. So hopefully you paused the video and figure that out. Let's check your answer. So a triangle has 3 vertices, so it'll have 3 lines of symmetry. So you take 360 and you divide it by 3 to get 120 degrees. So if you rotate this triangle 120 degrees, it will look exactly the same as what you started with. If you rotate it again, 240 degrees in total, so it would be another 120 degree rotation added on, it would look exactly the same. And that's it. It's very simple. All you have to do is count the number of vertices and divide 360 by the number of vertices to get the angle of rotation for regular polygons, which is, to what degree can we rotate a figure to have it map onto itself? Hopefully you